Hello, boys and girls. Today we're going to talk about your lesson, convection and the mantle. We're going to talk about types of heat transfer and how they actually happen inside of the Earth. All right. I needed you guys to actually go over the theory of your lesson before I started talking about these different concepts. Okay. So I hope that now that you have the idea of them in your heads, this visual representation can help you guys out to understand them a lot more. Okay, so the first of all, we gotta talk about heat transfer. What is heat transfer? Heat transfer is any way in which heat or high temperature is transferred from one object into another. The object that is transmitting that temperature, that heat, is also called the source of the heat. Alright? So, there are three ways in which heat can be transferred from the source to another object. According to your book, the first one is actually radiation. Radiation. But I believe that it's better to actually talk about conduction first before talking about radiation. So for this, I'm gonna use this this candle over here to help me out. Okay, if I grab a match, okay, and I turn it on, and I actually light the candle on fire, what was I doing there? I grabbed fire from this match and transferred it into the candle. The conduction of heat through direct contact is called conduction. Okay, so this match was directly touching the candlestick, and that's how the heat from the match was able to turn on the candle. Okay, all right, so that's the first type of heat transfer. The second one is radiation. Radiation happens through empty space. It doesn't require physical contact between the objects. It only requires that there is space in between them and that the heat can be transferred through it. If I grab my hands, for example, and I put them like that near the candle, I can feel the heat coming from it. I can put it here, for example. You can see that my hand is not touching the candle, but I can still feel the heat. It's quite hot, actually. There comes a point where I have to remove my hand because if not, it's going to burn it, right? But how is that possible then? I'm not touching the flame, but it's still burning me. That's because heat is also a form of radiation. Okay? Is a byproduct also of radiation. Okay? So, heat can pass through the empty space, through this empty space over here, from the candle onto my hand, without the need of physical contact. And it will still burn me. Okay? I can even have physical contact with the flame, and as long as I don't take too long working with it, I will not be burned, but I can still feel it. So, first of all, conduction. Direct transfer of heat through physical contact. Radiation. Indirect transfer of heat without the need of physical contact. I don't need to touch this to feel the heat. Same thing when you're working in your kitchen, right? In your stoves, maybe you're cooking something and you feel the warmth coming from that stove and from your food. That's because of radiation. It's coming through you. Okay? What happens if I grab, for example, a spoon and I put it inside a pot that is filled with hot soup? The spoon is gonna get really, really hot also, right? Why is that? Because the conduction from the soup through the spoon into my hand is able to occur. Okay? So, you need to focus on those two things. One requires physical contact, the other one does not. Alright? for the next explanation, for convection, I need a little visual aid. So for convection, I needed a little extra visual aid, and boys and girls, so here it is then. I present to you a lava lamp. Okay, what are lava lamps? Well, they're how can I put this? They are what many of us considered to be entertaining back then. We would buy them and we would have this arrangement of colors and wax inside of it and just observe it. That's how you would entertain yourself back then. But okay. However, lava lamps actually demonstrate the principle of convection very how can I put it? Very precisely, actually. Precisely what? Okay, what is convection? First of all, convection requires a liquid or semi-liquid environment to happen. How does convection work? It first of all needs a source of heat. In here, at the bottom of the lamp, there's a light bulb, and that light bulb is emitting heat through radiation that warms up the water, which in turn warms up the wax inside of it. The red thing is the wax. Okay, so convection happens in this lava lamp. Convection happens through wax and radiation, and partially also through conduction. But let's focus on convection then. Convection works this way. As the materials fall down closer to the source, they warm themselves up. The heat that is being transferred warms them up, and so they expand. This wax expands itself, so it becomes from tiny little bubbles into big ones. So how does that happen? How is that called? That is actually called a change of density. That means that these bubbles are no longer as compact as they were once they are coming down. Okay, so they expand once they are heated up, and they become a little bit larger than they should, which means that their density decreases. That decrease in density allows them to float. So that's why you can see many of them floating upwards, okay? Because their density is less. So they can float upwards. But as they reach this point over here, they start cooling down. And when they cool down, their density increases, basically. They become more compact. So because their density increases and they are more compact, they drop down to the bottom again. And they heat up, their density decreases, so they expand, and they float again. They come to this point over here, and their density increases, so they compact each other. And they fall down to the bottom once again. And it's a cycle that never ends, okay? So the wax basically heats up, expands, and floats. Once it is here, it cools down, it contracts, and falls back down to the bottom, and so on and so on. Okay? So that's how convection works. The transfer of heat occurs in a liquid medium, and as the bubbles or the material start moving upwards, they also carry heat with them. Okay? That's convection. And what does convection have to do with the mantle then? Well, it just so happens that convection also happens inside of the mantle. In here, they're giving us an example also. Think of a pot of soup, and here's your stove. And it's the same principle. The water that is closer to the bottom gets warmer, so it rises up with the bubbles. But once it cools down, it falls back down to the bottom, and so on and so on. The same thing happens with the mantle. Molten rocks and other materials that are close to the core of the earth warm up. And when they warm up, they expand and they float to the top of the mantle. But at the top of the mantle, they cool down. So they contract and they drop back down to the bottom. And the cycle repeats itself over and over and over. Why is this important to us? Why are we affected by this? Well, it just so happens that this motion over here, this cycle that is being created by convection, moves the crust of the earth. And that's what causes earthquakes, volcanoes sometimes. There are many, many ways in which these convection currents affect us. So it is important for us to know how the process of convection actually works. Okay? But for now, let's focus on that. Don't focus on the effects of convection. Focus on how it works. On our next lesson, we're actually going to talk about that. How does convection affect the earth? I hope you guys liked the video, and thank you for watching.